Hello everyone, myself Pavitra YS from Department of Information Science and Engineering, Sri Venkateshwara College of Engineering. Today I'm going to talk about a subject called cryptography. The contents which I have chosen are Introduction to Cryptography, Substitution Technique, Playfair Cheaper, Hill Cheaper. Introduction to Cryptography. Cryptography is the practice and it is a study of techniques for secure communication in the presence of adversaries. It involves the use of mathematical algorithms to transform plain text into the cheaper text, making it unreadable to unauthorized individuals. Cryptography ensures confidentiality, integrity, and authentication of data and the messages. Now let's look into the definition of cryptography. Cryptography is the science of writing and solving codes, chiffres, and algorithms. It encompasses various techniques such as encryption, decryption, digital signatures, and key management. The main goal of cryptography is to provide secure and private communication, ensuring that information remains confidential and tamper proof. Importance and some applications of cryptography. Cryptography plays a crucial role in ensuring secure communication over the internet, protecting sensitive information such as the passwords, credit card details, and personal data. It is widely used in offline banking, e-commerce, email communication, and secure messaging applications. Cryptography is also essential for secure storage and transmission of classified government documents, military communications, and protecting intellectual property. Let's look into the classical encryption techniques. Classical encryption techniques are of two kinds. One is the symmetric cheaper model and the second one is the substitution technique. Symmetric cheaper model consists of cryptography and cryptanalysis and brute force attack, wherein the substitution technique consists of Keyser cheaper, monoalphabetic cheaper, Playfair cheaper, Hill cheaper, polyalphabetic cheaper, one-time pad. What is substitution technique? The substitution technique is a method which is used in cryptography to encrypt and decrypt the messages. It involves replacing each letter of the plain text with another letter or a symbol. This technique is commonly used in classical chippers such as the Keyser chipper. Now let's look into how the substitution technique actually works. In the substitution technique, each letter of the plain text is replaced with the corresponding letter or symbol from the cheaper alphabet. The cheaper alphabet is simply a rearrangement of the regular alphabet. For example, in a Keyser cheaper, with a shift of 3, A is replaced with D. That is, with a shift of 3, 1, 2 and 3, this A is replaced with the D. And then B with E. B is replaced with E. B with a shift of 3. 1, 2, 3. B is replaced with E. And it continues so on. Let's look into an example of substitution technique that is from the Keyser cheaper. Let's consider the message hello and apply a Keyser cheaper with a shift of 3. The plain text letters HELLO would be replaced with KHOOR respectively. H. In the place of H, after a shift of 3, it can be replaced with K, that is H. After H comes I, J, K. K is in the third place after a shift of 3. Thereby, H is replaced with K. E. After a shift of 3, F, G, H. H is in the third place, thereby E is replaced with H, and so on. The encrypted message would be KHOOR for the plain text letters HELLO. Here are some advantages of substitution technique. The first advantage is that the substitution technique provides a simple and a straightforward method of encryption. Second comes, it can be easily implemented and it can be easily understood even by the individuals with limited cryptographic knowledge. It can be used as a stepping stone to more advanced encryption techniques. Limitations of substitution technique. There are few limitations which are involved in the substitution technique. Firstly, the substitution technique is vulnerable to frequency analysis attacks. Second, if the cheaper alphabet is not properly randomized, patterns in the plain text may still be visible in the cheaper text. Third comes, it can be easily broken using brute force techniques or by analyzing letter frequencies. Next topic is Playfair cheaper. The Playfair cheaper is a symmetric encryption technique that was invented in the year 1854 by Charles Wheatstone. It is named after Lord Playfair, who promoted its use during the Crimean War. The cheaper is a type of substitution cheaper where each letter in the plain text is replaced by another letter. Now let's look into how the Playfair cheaper actually works. The Playfair cheaper uses a 5 to 5 matrix of letters known as the key square to encrypt and decrypt the messages. To create the key square, a keyword or a phrase is chosen and any repeated letters are removed. The remaining letters of the alphabet are then added, excluding the letter J, which is usually combined with I. Here we can see that I can be combined with J. 5 into 5 in a sense, we have 25 boxes. Usually J is used rarely, thereby it is combined with I. Rules for Playfair cheaper. Here are 5 rules which we need to follow while solving the Playfair cheaper. First rule is that we need to draw the 5 into 5 matrix diagram. Then whenever the letters are repeated in the same, that is like L, L, A, A, we have to use filler letter. That is, the filler letter is nothing but the X. When the letters are present in the same column, then we have to follow the rule called the wraparound. When the letters are present in the same row, even then we have to use wraparound. Rectangle. If the letters are present in the rectangle, that is, for example, A and T. Here we need to form a rectangle. When it forms a rectangle, we need to follow the method called swap. That is, A is swapped with R and then S is swapped with T. Here we have to form a rectangle only for the letters which we have taken. Example for encryption using the Playfair cheaper. Let's say we want to encrypt the message attack using the keyword monarchy. The key square for this example would be, the key square involves, first we have to fill with monarchy and then the remaining boxes should be filled with the letters which are not present in monarchy. We divide the message into pairs of 2 letters, resulting in these attack. The word called the attack is divided into 2, AT, TA and CK. Example of encryption using the Playfair cheaper. Continuing with the previous example, AT is encrypted with RS. A is present here and T is present here in this matrix, 5 into 5 matrix. And here we have to form a rectangle. That is the 5th rule. After forming a rectangle, A is swapped with R and then T is swapped with S. Thereby it is RS. Next comes TA. T and A. Even here we have to form a rectangle. Here A is swapped, R is swapped with A and this T is swapped with S. Thereby SR. And then comes CK. C is present here and the letter K is present here. Even here we need to form a rectangle. C is swapped with D and K is swapped with E. Even this follows the 5th rule. This is done using the rules which we have explained earlier. Therefore, the encrypted message for the word attack using the keyword monarchy is RSSRDE. The encrypted message can now be transmitted securely as it appears as a random combination of letters. Decryption using the plaintext cheaper. Now the same word which has been encrypted can be decrypted. That is, we'll get the original word which we have encrypted. To decrypt a message encrypted with a plaintext cheaper, the process is simply reversed. Using the same key square and keyword, the encrypted message RSSRDE can be decrypted back to the word attack. The same rules are applied, but it has been applied in the reverse order to locate the letters in the key square and retrieve the original plain text. Let's look into other examples which follows the other rules. First example is mosque. Firstly, we have to divide the letters into two, MO separately, SQ separately, and UE separately. MO, M and O. These letters are present in the same row. Thereby, they have to be wrapped with the next letter. M is wrapped with O, and then O is wrapped with N. Then comes S and Q. S and Q, even here they are present in the same row, thereby they are wrapped with the neighboring one. S is wrapped with T, and the letter Q is wrapped with S. UE. U and E, they are present in the same column. Thereby, U is wrapped with M. U is the last word in this, U is the last letter. Thereby, it will go, it makes a cycle. U is wrapped with M, and then E is wrapped with L. Next example is collage. Uh, Now let's divide into two letters. CO separately, LL. Here we have a repeating letters. Thereby L. After L we have to place an X. Thereby the letters will not be repeated. And then LA, and then GE. C and O. C and O. Here we should make a rectangle. Thereby O is being replaced with M, and similarly H has been replaced with C is replaced with H. L and X. L, X is present here. Even here we have to form a rectangle. Thereby L is swapped with S, and X is swapped with U. L A, L and A. Similarly, here forms a rectangle. L is replaced with S, and similarly M is replaced with M. G E. G is present here, and E is present here. They are in the same row. Thereby, they have to be wrapped with the neighboring one. G is wrapped with I, and then E is wrapped with F. Next comes a concept called Hill cheaper. The Hill cheaper is a polygraphic substitution cheaper which is developed by Lister S. Hill in the year 1929. It is a symmetric encryption technique that operates on blocks of plain text letters instead of individual letters. The Hill cheaper uses linear algebraic concepts to encrypt and decrypt the messages. How Hillchipper actually works. The plain text is divided into two different blocks of fixed length, typically 2 or 3 letters. Each block is treated as a column vector, and it has been multiplied by a matrix called the encryption key. The resulting product is then converted back into the letters to obtain the cheaper text. Here is an example of Hillchipper. We have taken a plain text called pay more money. The cheaper text when we convert these is, for pay it is RRL, more MWBK, and for money it is ASPDH. Here is a formula wherein we get this. The formula for the Hill cheaper is that C is equal to E of K comma P mod 26. Here we have written this in a matrix form, and it goes like this: C1 C2 C3 is equal to P1 P2 P3. P1 P2 P3, we are solving this for PAY. P1 is nothing but P, P2 is nothing but A, and P3 is nothing but Y of K K11, K12, K13, and in the next column comes K21, K22, K23, and the next row K31, K32, K33 of mod 26. Now we have to solve this. C1 is equal to P1 into K1. We have to multiply each letters, that is the P1, P2, P3 with the corresponding one. P1 is multiplied with K11 and then P2 is multiplied with K21 and then P3 is multiplied with K31. And similarly C2. C2 is equal to P1 into K12 and then P2 is equal to K22 and then P3 is equal to K32. We have to go in a column wise. Then comes C3 is equal to P1 into K13, P2 is equal to K23 and then P3 is into K33. This all should be multiplied with the mod 26. Here is the brief explanation about the example. We have been solving only for the word called pay. P is nothing but P1, A is nothing but P2 and Y is P3. P is in the position 15th and A is in the position 0. We start with 0 usually and then Y is equal to 24. Uh, Here is an example which we have to solve and here is an int, that is A is equal to 0, B is equal to 1, C is equal to 2 and so on. Thereby we'll be having 25 letters, that is that which ends with Z is equal to 25. Now we need to solve this as we have seen in the previous slide. How to solve this we have seen there. In the same way we have to solve this problem. Now we have to do P1 into 17. P1 is nothing but 15, thereby 15 into 17. P2 is 0. 0 into 21 is nothing but 0 and then P3 into 2. When we do this, we'll get a total of 303 of mod 26. 303 of mod 26 is nothing but 17. Then C2. C2 is equal to P1 into 17, that is 15 into 17 plus P2 is 0. 0 into 18 is equal to 0 and then P3. P3 is 24. 24 into 2. We get a total of 303 again and 303 mod 26 is equal to 17. Next comes C3. C3 is equal to P1 into 15. P1 into 5. That is 15 into 5. Next comes P2 into 21. P2 is 0 into 21 is 0. P3 is 24. 24 into 19. And we get a total of 531. 531 mod 26 is nothing but 11. Now, when we take this total, the letter which has been present in the 17th position is nothing but R. And the letter which has been present in the again the 17th position is R and in the 11th position is 11. Thereby PAY, when we convert, we'll get RRL. This is the way we solve the hill shaper. Here I complete with my topic. Thank you. Have a nice day.